Over 100 years ago, Viking Pump started as a single pump in an Iowa quarry. Now, we are a global manufacturer with products shipped all over the world. We employ the best people to work in our state-of-the-art facilities, and we build our highly engineered products from the ground up. And that's why Viking Pump is the global leader in positive displacement pumping solutions. Cedar Falls, Iowa is home to Viking Pump's world headquarters, and this is where the pump design process begins. Viking Pump is located in the original building the company was founded in over 100 years ago. Over the years, the building has undergone multiple expansions and formerly housed both manufacturing and office staff. As Viking grew, additional space was needed and manufacturing was moved to the Cedar Falls Industrial Park. Today, the downtown Viking Pump headquarters is home to the executive offices, customer service, accounting, human resources, IT, marketing, engineering, and the engineering lab. The process for manufacturing a Viking Pump starts in one of Viking's foundries. The Viking Pump Alloys Foundry is located 2 blocks south of Viking Pump headquarters. When this facility was originally acquired by Viking Pump in 1929, it was used to cast brass and bronze. As Viking's market shifted, this foundry was transitioned to other metals to align with our chemical, petroleum, and food markets. Viking's Iron Foundry is located on Viking Road in the Cedar Falls Industrial Park. At 78,000 square feet, this foundry is the larger of Viking's 2 foundries. Originally located closer to the downtown sites, this foundry relocated in 1976 to be adjacent to the machine shop. A casting storage area connects these 2 Viking Road facilities. In a foundry, parts are cast by pouring molten metal into a hollow mold. To create a mold, patterns are pulled for the various cast parts required. Each pattern is a template for one side of a cast part or multiple parts. Sand will be compressed against the plate, and when the plate is removed, the shape of the part remains and half of a mold is created. Here, a pattern is prepared for some internal gear pump heads. A second, matching plate with the reverse sides of these heads will be used to complete the mold. Parallel to the mold making process, the metal is being prepared. At the foundry melt deck, a mix of raw ingredients and foundry scrap are mixed in a furnace. Periodically, the molten metal is checked for temperature and chemistry. If the chemistry is incorrect, additional components are added in specific weights to achieve the desired properties. When both temperature and chemistry are correct, the furnace is poured into a waiting foundry ladle. Impurities are gathered at the top and removed from the crucible, and a sample bar from the heat is poured. The molten metal is now ready to be poured into the various part molds. Timing is critical to ensure that the temperature of the metal is maintained high enough to complete the required number of parts. Each mold then sits for a period of time to cool and solidify the metal part. Once cooled, the mold is broken and the rough casting is cleaned. Excess metal is cut away and recycled, and the rough edges are ground smooth. Some materials, like stainless steel, require heat treatment. These parts are heated in an oven and cooled in a water bath. Finished castings head to the casting shed before heading off to the machine shop. This is the transition point between the foundry and machining. Viking's largest facility is the machine shop. Since its opening in 1960, this facility has undergone multiple expansions and grown to 320,000 square feet. Today, this facility houses many departments, including machining, tooling, assembly, paint, shipping, quality, procurement, and planning. In the machine shop, parts are machined from castings and bar stock. Dimensions, especially those inside the pump cavity, must be precise to ensure the pumps operate efficiently and are capable of high pressures and self-priming. Quality checks are made throughout the machining process. In the sub-assembly area, individual parts are pressed or pinned together into sub-assemblies. Examples include rotor and shaft assemblies and idler and bushing assemblies. These and other parts are gathered together for final assembly. In final assembly, parts and sub-assemblies are put together as a complete pump according to the pump's bill of material. Each Viking pump receives a quality test prior to shipping. For most pumps, this involves a run test and hydrostatic pressure test. Pumps requiring certified testing are transferred to the Viking Product Engineering Lab. Here, pumps are tested at the customer's specified speed, pressure, and liquid viscosity to ensure performance to the customer's unique application requirements. These tests may be complete unit tests or performed on one of Viking's 9 dynamometers to measure the power required. Once the pump has passed all testing, it can be staged for paint. In painting, most pumps receive a coat of Viking blue paint. For external gear products, this is a UV Cure epoxy paint. For other products, this is a water-based paint. While many pumps, especially those for replacement, will be shipped individually, others need to be built into a complete unit. Viking units would include the base plate and can also include the motor, couplings, guards, reducer, or V-belts. Here, an external gear pump unit is being fabricated and factory aligned. Completed pumps and units are now boxed and shipped to Viking distributors and customers all over the world. Over the course of more than 100 years, that's been over 6 million pumps and counting.